Welcome everyone to the Cavirin webinar, Closing the SecOps-DevOps Security Gap. With me today is Basham Anat, our VP of Product Management at Cavirin. Good day, Basham.
Good day, Dave.
And then myself, Dave Ginsberg, I'm responsible for marketing. And without any further ado, Basham, your turn to take over.
Thanks, Dave. So today we're going to talk about closing the SecOps-DevOps security gap using a key strategy that we call closed-loop security. Now, our agenda for today, I'm going to give you a very quick overview of what Cavirin Cyber Posture Intelligence stands for, and then talk briefly about the SecOps-DevOps divide that we started noticing among our customers, how you can mitigate that using what we call closed-loop security. And then we're going to present two examples of closed-loop security, one for operating systems with respect to golden state configuration management for them. And then Dave will actually show you a demo of applying the same principles for cloud security as well, and then we'll wrap up with next steps. So what does Cavirin do? So imagine you're a company and things are going really well, and you've set a good baseline from a security posture perspective for your organization, but your engineers go off and they start adding new services, they start adding new applications to your environment and so on. So what happens very quickly in most organizations is some user error or something else goes on that results in services being misconfigured, users being assigned more permissions than was anticipated, and so on. And very quickly, from a good baseline, you start deviating to a position where it's not so optimal. So what Cavirin actually does for you is, from a continuous posture monitoring perspective, it presents a dashboard for you in terms of how your security and compliance posture looks like at any given moment in multiple clouds, as well as in on-premises operating systems. And then last but not least, once we give you a sense for where you stand, we also help you remediate those findings that we find using a prioritization approach, which is based on our proprietary cyber posture algorithm. So again, the idea here is we monitor, tell you how you're doing, and then help you remediate. And a big portion of today's talk is really around how you actually automate the remediation process itself from a system like Cavirin. Now, in terms of what the end user actually sees, here's an example of a dashboard from the Cavirin product. This is what SecOps teams typically spend a lot of their time on. And what it's giving you at a glance is, for your entire environment, it's telling you how you're doing from an overall cyber posture perspective. In this example, it's a 93, how that breaks down between security concerns versus compliance concerns. And on the left-hand side, there is a filter panel that lets you drill down and diagnose what's going on in your environment between 5 different environments like GCP, AWS, Azure, Docker containers, as well as the on-premises environments, as well as other filters like we have about 55 to 60 odd operating systems and distinct cloud services that we also profile. So again, you can drill down in any of those dimensions and find out how your cyber posture looks like along those dimensions, so that you can very quickly pinpoint what's going on and where you need to act. The arrow that's marked number 2 actually shows you a list of prioritized issues for any flavor of things that you're looking at in the dashboard. So this prioritized issues is based on a cyber posture scoring algorithm that we've come up with. And the main idea here is that if you remediate the issues in the order that's displayed here, then your cyber posture for the collection of assets that's in the scope of the dashboard will actually improve by that particular amount. And last but not least, there is also a trend line that you can actually get to look at to see all the change actions that you're taking in your environment, what's the effect of those from a overall cyber posture perspective. A key prerequisite for doing any of this is actually visibility. So what Cavirin is actually doing is it's actually finding what you have as a first step. And as I said before, it's essentially 5 different environments: AWS, GCP, Azure, Docker, and roughly 22 operating systems. So as this list suggests, there is about 55 or 60 things on this list of distinct operating systems and services that we actually profile, discover and profile from a security and compliance posture perspective. Now, what is the SecOps-DevOps divide? Again, in many organizations, what we are seeing is you've got your developers, or in general, DevOps people that are actually, like I said before, developing new applications, consuming new services, and doing this at a very fast pace, right? So when that happens, a common thing that happens is, services get misconfigured, users get permissions that they are not supposed to have, and so on. And so very quickly you go from a good state to a not so great state, and that's where your SecOps users start observing deviations in your environment from a security or compliance posture perspective. And the gap that we're getting at is really the fact that while SecOps users might have visibility using different monitoring tools, the reality is that given the fact that remediation is a manual and time-consuming process, it takes a long time, and more importantly, your environment or your company is vulnerable to breaches because of a time-consuming manual process when it comes to remediation. Now, a big goal for this talk is to actually talk about how you can actually overcome those kinds of weaknesses in your system by automating and linking monitoring solutions like Cavirin with remediation and orchestration systems like Ansible. Now, a key principle is what we call closed-loop security. That actually comes down to 5 different pillars that Cavirin has identified with respect to how this is supposed to work. So at the core is really around identification. This is really identifying and discovering all your assets. The second step is protect, which really refers to evaluating your infrastructure against roughly 80,000 different technical controls, some of which have been authored by Cavirin. Others are from best practices and guidelines from AWS, GCP, Azure, and so on. Once we do that assessment of technical controls, we have a sense for where you stand, but that's not by itself is not enough. We also actually monitor your security posture on an ongoing basis and detect drift. And then the most important thing is once we do find out issues and prioritize them for you, the main idea here is to automate the remediation or the response plan for the findings that the Cavirin product generates. And as the slide suggests, the specifics of the remediation actually depends on the environment you're in. So for example, in the case of cloud services, your remediation would be based on serverless technologies like AWS Lambda, which is what Dave will demonstrate today. Or if you have operating systems that you're trying to harden, there your approach might be based on a config management system like Ansible. And the last but not least, if you're using a container environment, you're probably going to be using an orchestrator like Kubernetes to enact your remediation. And finally, as it relates to the changes you're making, you also want to take stock of, did these changes have any effect, right? So for that purpose, there is a predict step, which is really around computing the cyber posture score. Again, it's just a number between a 0 and 100. 100 represents the least amount of risk. And we can compute that on an ongoing basis to help you understand where we are, where you stand from a security and compliance posture perspective, and the cycle continues. Now, applying that to operating system security, very quickly, the main idea here is that we're going to be using a benchmark like the CI's policy pack to assess where we stand and monitor that on an ongoing basis. And in our demo today, we would remediate any findings that we generate from the Cavirin system using a config management system. Ansible is the one that we've integrated today, and then see the effect by projecting the scores one more time. Now, our customers, basically, the way they enact operating systems is really actually take a look at it from 2 perspectives. In one case, it's actually looking at hardening the operating system's pre-production. Now, in this example, the arrows are marked 1, 2, 3, 4, 5. The idea here is that before, in the pre-production environment, this particular organization, they would create 5 or 10 base images based on their security standards. Let's say you can create like 5 Windows images, 5 Linux images, and you expect all your DevOps teams to be using those as a standard for when they compute, when they create compute instances. Now, once you build those base images, you can actually do a workflow where you evaluate those images against the rules of technical controls that are there in the Cavirin system, get a score, and if your score is good, in this example, we used 80 as a benchmark for a good image, you would promote those images to production. If not, you would remediate them. And remediation, like I said before, involves generating a bunch of Ansible artifacts, which are really listed here. So the variables file reports the list of policies or rules or technical controls that we expect Ansible to remediate, and then the hosts file refers to the list of machines that Ansible has under its management, where we want to target remediation. And then the final step is using the Ansible system itself, along with the playbook and the variable and hosts file, to remediate and harden the machines to a golden state, after which you publish them to a repository, and your DevOps team start using it. Again, that's an example of applying the same principles in pre-production. But more interestingly, in production, as we said before, changes happen all the time as your DevOps teams are using your infrastructure. So here's where the real value of Cavirin actually shines, which is really around discovering new resources as they are getting consumed, new resources, services as they're being consumed by your teams, assessing them or monitoring them against the technical controls that we have in the mix, automatically generating the Ansible artifacts, which are really the host files and variable files that I described before, and then invoking Ansible to run playbooks that will harden the deviating machines and restore them to a golden state, and that's what we'll see in the demo next. So in this demo, what I have here is the actual Cavirin product, and the first thing that you'll notice here is that I have an asset group, which is called the RHEL7-91 asset group, that contains a bunch of Red Hat machines, which at this point in time have a cyber posture score of 63 based on the CIS controls that I've evaluated on them. So the first thing to do actually is to essentially to run an assessment on this asset group. And because this was set up previously, we already have some results. But one of the things that you do want to look at is you can actually set up what we call suppression profiles, which represent the list of controls or rules that you are interested in as an organization that represents your security standard. And that's really what the user is actually doing at this point. In this case, the network configuration is a set of policies that you don't care about because you have compensating controls. And so you just mark that for audit purposes, suppress them, and run an assessment. Now you can see that the asset group is in what we call pre-scan state. That just represents that you're going off and discovering any new resources in the asset group. And once the assessment completes, the score comes back for the RHEL7-91 asset group with a score of 65. Now, one of the things you'll notice, the next step in the demo is actually to look at the artifacts that the Cavirin system generated. So like I said before, we expect a couple of artifacts to be generated here. The first is called the inventory of the hosts file, which you can take a look at. And then the second is a var file or variables file that is really the list of policies that Ansible is expected to remediate. So let's take a look at the hosts file first. Again, and for the sake of simplicity, it simply identifies the operating system and then the particular IP address that is under management and refers to that particular machine. Next, if you look at the variables file, you'll see a whole bunch of CIS rules, and then there is a true or false next to each rule, right? So if you see a true, it means that that's an instruction to Ansible to remediate that particular rule. If you see a false, that means the policy does not require remediation, either because it's suppressed, because of the suppression profile that I set up, or users don't really care. Now, having said that, the next step in the process is to go to the Ansible control plane, as you can see here, and then the first thing to do here is to run what we call the fetch playbook. The fetch playbook actually copies the artifacts that are lying or residing on the Cavirin system at the moment and copies them over into the Ansible control plane. And that's, so once this particular playbook runs, you can see that you can see now at this point Ansible is running the playbook, and again all it's doing is a copy operation from Cavirin into the Ansible control plane. Next, let's take a look at the Ansible playbook for Red Hat. What you'll see there is a reference to the variables file. Again, the variables file references the asset group along the operating system. And the next thing to do here is to actually run the playbook. And here one of the things you'll see a reference to the inventory file, which we had generated previously, which the Cavirin system had generated automatically previously, and we run the playbook. This would take a few seconds here. Once that's done, you can actually go off and verify by running a assessment one more time for the same asset group. Once the assessment completes, you can actually go back and also verify on the dashboard to see if the scores have indeed improved. So the RELS-7-91 asset group is what I was looking at. The score is a 65 after remediation. And you can actually take a look at the particular rule that you're looking at. It was actually related to the CRAM-FS file system. That's the one that Ansible has remediated. And what you see here is that that particular finding no longer appears in the list of prioritized issues. So that was it in terms of my demo. So let me go back to my slides. So what I discovered was really around applying closed-loop security for operating system assets. The next up is a topic that I want to hand off to Dave in a moment here. But this really refers to actually applying the same closed-loop security principles for cloud security. And here again, like I said before, it's about identifying resources or services that you're using in AWS, Azure, and GCP. Creating golden posture standards using cloud control frameworks in this case, monitoring your resources using whatever eventing mechanisms are available in the different clouds. So for example, in the demo, you'll actually see AWS CloudTrail being used, but had it been GCP, you'd be using Stackdriver. And so the idea here is to get those events and assess if your resources are actually different compared to the golden state. And then the remediation of the response plan actually involves automating the remediation using serverless functions. In the case of AWS, it's about using AWS Lambda. But in the future, you might be using, if you're on Google and you're remediating assets in Google, you'd probably be using Google functions. And then last but not least, predicting the impact on the score of the changes you make. So a quick word on the architecture. So when it comes to monitoring, again, this is a template and a best practice in terms of how this is being set up. But the basic idea here is that if you follow the arrows from 1, 2, 3, and 4, 1 represents monitoring events using CloudTrail, and then secondly, again that's done by Cavirin as part of the setup of the monitoring feature. And then we also set up a CloudWatch, set of CloudWatch alarms or metrics, if you will, to actually filter the events that we're looking for from CloudTrail. And based on the CloudWatch filters, we have a Cavirin Lambda function that is actually posting events which are based on evaluating those events from a security or threat perspective. So if the filter matches what we are looking for, step number 3 is about publishing or filtering those events and publishing those a filtered list of events to the SQS queue, that is Simple Queuing System queue, which is what the Cavirin server is listening to, and publishes them or presents them to the user in the dashboard. So again, that's the blueprint for how monitoring works behind the scene. And if you look at how remediation works, so again, here you'll see this a little bit more clearly in the demo. But the idea here is that from the dashboard, you'll see a list of prioritized issues. The issues that are actually remediatable using Lambda functions is actually rendered to you in this list. And the user can pick one or more issues based on their improvement potential, like you see here, and so also select one or more resources that they want to remediate from the list on the right-hand side and hit the remediate button. At that point, the remediation happens, and the architecture for remediation looks something like this. So again, if you follow the arrows marked 1, 2, 3, 4, 5, the idea here is that the user issues the action to remediate. That's step number 1. That results in a message being published to an AWS SNS topic. The SNS topic is being polled by a second Cavirin Lambda function that is looking for things to remediate. So that's step number 3. So the Lambda function picks up those from the SNS topic. It picks up the findings that it needs to remediate, and then uses the Lambda function goes off and remediates. In this particular example, and in the example that Dave will show you, it's actually remediating ports in security groups, and then fixing them using the Lambda function. And then once we get a confirmation back from AWS, we push the confirmation notifications to a SQS, again, a Simple Queuing Service system, which then, again, the Cavirin server is listening for as part of step number 5, and that completes the cycle from the remediation workflow. So let's take a look at a demo that Dave will show us in the next few minutes.
Thank you, Basham. What you see here is the Cyber Posture Dashboard. In particular, AWS, which is the environment that we looked at. We created a asset group, and then we assessed against Network Policy Pack. When we do that, we're going to identify the various resources across our AWS accounts and what their security posture is at a given point in time. So when we move over to the Resources tab, I can go ahead and sort on the cyber posture score, and I can also go ahead and sort on the service that I'm looking at in particular. In this case, it'll be the security groups, and you'll see that a number of them have a 0, which means their ports, both incoming and outgoing, are open to the outside world. So let's look at one particular security group here. And what I'll do after looking at it on the resources dashboard, we'll actually move over to the AWS console. We'll sort on that security group. And you'll notice, if you look at the individual ports, they're really the default in terms of open access to the world, both inbound and outbound. What we want to do is remediate that. So let's go back over to the Cyber Posture Dashboard. On the right side, you'll see a list of prioritized remediation actions. And I can click on the box in the upper right, and that'll get me to my Lambda remediation screen. I'll pick my specific security group, the one I looked at earlier, and in a matter of seconds, the remediation action has taken place. So I can verify that using the AWS console. You'll see that the ports are now closed down. But what I can also do is rerun the assessment, And remember that I had a score of 0 before. So I'll go to my asset groups. Let me go ahead and rerun it. So now it's going through the reassessment. There's a couple stages that involve pre-scanning and then the assessment in progress, and then it will complete in a minute or so. It's completed. I can now go back to my Resources tab. What I'm going to do is filter it, so I'm only looking for AWS security groups. I'm now going to sort on the cyber posture score itself. You'll still see a number of zeros, which are security groups that I've not remediated that are still open to the outside world. But as we scroll down a little bit, you'll come to some that are at 50. So these are ones, in this case, the one that I just did the remediation action on, and it has changed from a 0 to a 50. Obviously, if I went and dealt with the outbound ports as well, I would be able to bring that up to 100. Now, this type of remediation action I can do under individual security groups, or I can slice and dice the AWS account infrastructure I have by my various VPCs or by other ways of looking at the assets to give me additional granularity. Just to summarize, what you're seeing here is a generalized view of our cloud workflow across AWS, Azure, and Google Cloud, as well as looking at on-prem or cloud workloads. They're combined into the Cyber Posture Score and presented to the dashboard. If you want to learn more, additional resources are available at the following URLs. First of all, auto remediation, where we talk about the Ansible playbooks as well as AWS Lambda functions. It's a blog that we put out. Second, please go to our free trial page where you can spin up 1 month proof of concepts from the AWS Marketplace, from Azure Marketplace, or from Google Cloud Marketplace. And last but not least, we talked about the Google Cloud Security Command Center integration. So that URL directs you to a landing page that talks about the integration, as well as what it means if you're trying to maintain an end-to-end view of your hybrid cloud infrastructure focused on Google Cloud.